Hello, Algebra students, Mr. Lawrence here, and we're on day 2 of solving equations. And these equations look pretty complex, but you know what? You can handle it. It's not that bad. Let's get right down to it. I'll tell you what. Why don't you do this? Excuse me. Sorry, my voice is going hoarse. It's, I don't know, 9:30 at night, and I've been talking too much. Imagine that, Mr. Lawrence talking too much. And my throat is getting a little tender. Not sore, just wants a break. So for right now, why don't you pause the video? You can see the first two equations. Why don't you go ahead and solve them? Unpause the video when you're ready to see my solutions, all right? Here, I'll give you a little music to think by. No, just kidding. Go ahead and pause. If you're watching right now and you haven't tried those two problems on your own, why not? Okay, here come my solutions. In problem number 1, I don't see anything I can do to the left-hand side of the equation to begin with. Can't put those together, not like terms. But I can distribute this 5, right? I can distribute. So I'm going to do that. I'm going to get 8 minus 3x. And that'll equal 15x minus 10. And then I'm going to, I don't like x's on both sides. I'll get rid of the x with the smaller coefficient. So I'm going to add 3x to both sides. And I'm going to get 8 equals 18x minus 10. And now it looks like a two-step equation. I don't know if you've noticed that. The goal, kind of, is to turn them all into two-step equations so I know how to solve them. Just do a few algebraic manipulations, and they turn into two-step equations, and all of a sudden it's pretty easy. And I'm not even walking through these steps at this point. I'm going to get x equal to 1. All right, I'm going to leave it to you to verify that that's true. Now this one here, hopefully you've already tried it, because here comes my solution. I'm going to get rid of this 3 by subtracting 3 on both sides. And I will end up with an x minus x over 5 equals 4. And I've made a small mistake. Hopefully you're watching. Emily, did you catch that? Yeah, I'll bet you did. You're pretty sharp, Em. I've been proud of you. Keep doing good work. Do your best. Make sure you're coming in for help. I've got a negative I forgot. Yeah, thanks to Emily, we caught it. So now I'm going to multiply both sides by 5. Only I'm not going to multiply by 5. I'm going to multiply by negative 5 because I might as well take care of that negative while I'm multiplying, right? I don't want to create an extra step. So when I do that, the 5s are going to cancel 1 to 1, and the 2 negatives will cancel out also, leaving me with just an x. And 4 times negative 5, negative 20. Dun, 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 dun. There we go. All right, now, the problems are going to start to look a little bit stranger, so pay attention. This stuff is easy. It is easy peasy, dude. I'm telling you, this is hard. Don't make a mountain out of a molehill. All right? And remember, best advice I ever heard. You can pick your friends and you can pick your nose, but you can't pick your friend's nose. And by the way, those of you who pick your nose in class, I see it. It's gross. Stop doing it. Anyway, you see this here? Some of you are going to see this fraction and you are going to freak out. You're going to go, I can't do it. I don't know. I go to the beach and people throw fractions at me and they steal my girlfriend and my yummy food. No, don't be a fraction wimp. Come on. Look, let's go back to problem 2 here. When we had a negative x over 5 equal to 4, we decided to get x alone by getting rid of this denominator, right? We didn't want that denominator there, so we multiplied. Well, what would happen if I got rid of this denominator? Now, I'm not going to get rid of x. I'm not going to get rid of 12. My denominator is x plus 12. So I'm going to multiply. Are you watching this? This is pretty cool stuff. I'm going to multiply both sides by x plus 12. And watch what's going to happen. The right-hand side, you say, hey, that just looks like a distribution problem. And you're right. We're going to get 7x plus 84. The left-hand side is the easy side because Wonder Woman does her thing. Notice I didn't do this. I didn't do this. Pay real close attention to this. Do not go x, x, and 12 12. No. Can't do it. These x and 12 are attached by addition. And division doesn't undo addition. But if I'm multiplying by the quantity of x plus 12, and here I'm dividing by the quantity of x plus 12, can't they cancel each other out? They sure can, leaving me a plain old x. So now it looks kind of like the first problem I did. I'm going to subtract x from both sides. Be careful here. I'm going to get 0 equals 6x plus 84. I'll subtract 84 from both sides. I'm going to get negative 84 equals 6x. I'm going to divide by 6, divide by 6. X is going to equal, let me see if I go in there, I'm thinking 14 times negative 14. Yeah, I think that's right. X equals negative 14. It really is a pretty simple problem. Well, number 4 is similar, not exactly the same. I'm going to tell you, though, I'm going to get rid of this, either the 6 or the 2 first. I'll get rid of one of them, and then I'll worry about getting rid of my fractions. So I'll tell you what, I'll subtract 6 from both sides. And when I do that, my left-hand side becomes x over 4, and that's going to equal x over 3 minus 8. Now, some of you are going to want to multiply by 4 to get rid of this fraction. I don't think that's a good idea. Some of you are going to want to multiply by 3 to get rid of this fraction. Some of you are going to stop and think, Mr. Turchak, are you listening? I'll bet you know a number that would cause both the 4 and the 3 to cancel. And I know you've got that puzzled look on your face, but I also know how smart you are. You're going to try, and you're going to tell me it's 12. You're absolutely correct. I'm going to find the least common multiple of 4 and 3. Well, it's 12. It's the smallest number both 4 and 3 divide into. Now, I'm going to multiply by 12 here, and I'm going to multiply by 12 here, and I also have to multiply by 12 here. Now, the 8 really didn't need to be over a 1, but since I wrote it that way, no big deal. Now, look, for those of you that aren't quitting this Wonder Woman thing, isn't 12 3 times 4? And, of course, we have times x over 4, right? And, 12 is 4 times 3 times x over 3. And then these I'm not going to write as a fraction. I'm just going to write like that. Now check it out. See the 4s? They cancel each other out. 3 times x, 3x. Here the 3's cancel. 4 times x, 4x. Negative 8 times 12, negative 96. And this is going to become a very easy problem. Now, some of you might have wanted to go right from here. You go, hey, 4 is 1, and 12 is 3, and 3 times x is 3x. Sure, absolutely. 3 goes into 12 4 times, 4x, right? Okay, there we go. So, tell you what, I'm going to do 2 steps at once here. I'm going to subtract 3x from both sides. And I'm going to add 96 to both sides. These will cancel. These will cancel. And my new equation, or new form of the equation, becomes 96 equals 4x minus 3x is x. And there you go. There you go. All right. How about number 5? You know what? It looks a lot like the last problem. I need the least common multiple. I need the smallest number both 4 and 7 go into. Well, I think that would be 28. Hey, by the way, it won't always be the product of the 2 denominators. Okay. So I'm going to multiply by 28 over 1. And over here, I'm going to multiply by 28 over 1. I can't multiply by 4 on this side and 7 on that side. It's an equation. 4 is going to go 28 7 times. And now I have to distribute. 7 times the quantity of x minus 1. 7x minus 7. Here, I'm going to cancel, and 28 is going to become a 4. And I'll distribute. And so I will get 4x plus 12. I'm going to subtract 3x from both sides. I'm going to add 7 to both sides. And I'm going to get 4x 7's cancel. Oop, I have a silly mistake, don't I? I sure do. I must have been thinking ahead. I'm not going to subtract 3x from both sides. I'm going to subtract 4x from both sides. Sorry about that. Okay, so that'll get me a 3x. Those will cancel, and I'll get a 19. I'll divide by 3, divide by 3. X will equal, 3 goes into 19 6 times. 3 times 6 is 18. That's 1 short of 19. And it'll be over 3 because I divided by 3. And there you go. The answer is 6 1/3. All right. Number 6. Well, you got to double distribute over here, right? Why don't we go ahead and do that? I'm just going to write x squared minus 7x plus 12. And that's going to equal x times the quantity of x minus 2 minus 5 times the quantity of x minus 2. And then I'll just write down this again. And that'll equal x squared minus 2x minus 5x plus 10. And so I have x squared minus 7x plus 12. And that'll equal x squared minus 7x plus 10. Then, I don't like that there's x squareds on both sides, so I'm going to subtract off x squared, leaving me with negative 7x plus 12 equal to negative 7x plus 10. All right. Well, I don't like that there's negative 7x on both sides, so I'm going to get rid of one of them by adding 7x to both sides. Look at that, I actually get rid of both. And I end up with 12 equal to 10. Hey, when does 12 equal 10? Never. 12 never equals 10. This problem has no solution. No solution. There you go. All right, that's your video for tonight. Hopefully it wasn't too much to handle. If you need to watch it again, you go right ahead. Where's my mouse? Mouse, there you are. All right, Mr. Lawrence signing off. Have a good night, everybody.